3, and then we add 3 to it as well. So then we're going to evaluate it. So I plug this in. Negative 3 goes there. It's a negative times a negative, which is a positive, and we turn that into 21 plus 3. 21 plus 3 is 24, and that's my final answer. All right? Next, this one's different though. This one is saying go find x. This one says it gives you x. Both of these give you x. This one says go find x. If I know the output of my function is y. This is the same thing as saying if y equals 10. All right? If y equals 10, then what does x equal is what this is saying. Then what does that equal? Well, what we have to do is set up an equation. My y value is equal to 10, or my output is equal to 10, which means up here, put the 10 right here into this spot, okay? Which means rewrite it this way. 10 equals what? Negative 7x plus 3. Right, like that, okay? So then what I'm going to do is solve this equation. And I solve this equation by subtracting 3 from both sides, right, like this. Cross those out, I get negative 7x equals, and I subtract that and I get a 7 there. So, and I'm dividing on each of these, and I finally end up with an answer there. Did I write that down correctly? Yep. Just double check yourself. Make sure you got it all written down correctly. Divide by negative 7, divide by negative 7, and you finally end up with x equals what? X equals negative 1. All right? And so that is our final answer. That's what x equals based on an an output of 10. That means what is it equal to? Set it equal to 10 and solve or evaluate for finding the x value in reverse, sort of thing. Hey, what about this one? This says use a different function. The other function is listed here. It's g of x. So what is g of 2? Well, that means go find the output if x equals 2. If x equals 2, then go substitute it in. And substituting it in means take the x squared and plug a 2 into that spot, and 2 squared is 4. Not too difficult, right? That one is just an answer of 4. All right? That's your answer on that one. Okay? Let's keep going. Almost done here. Okay, this is probably one of the trickier ones a little bit, but it's just understanding the notation that goes with a real-world problem. It says the temperature, degrees Fahrenheit of a turkey cooking in an oven can be represented by this. So that notation technically is saying that this T right here, this capital T, is temperature, all right? And it's going to represent the temperature is sort of what that is telling us. So what is the x variable? The x variable is defined, and it says where the input is x, and it says right here, is the minutes that the turkey has been in the oven. So you're going to throw it in the oven, you're going to start cooking this turkey, and the temperature will probably increase. So we would have a graph of probably something like this, and it would increase as time goes on. So time is here, and temp is over here, temp. All right, and so right here it says select one of these that matches T100. T100, T of 100 means that the input is what? 100. And this whole thing is representing a temperature. So this actually is telling us what's the temperature at what? At 100 what? 100 minutes. Because remember, the minutes is the x variable. Okay, so that's 100 minutes. Well, where's that at? That says right here, the temperature of the turkey after 100 minutes of being in the oven. All the other ones do not make any sense because the capital T stands for this is temperature based on an input of how much time it's going to be in the oven. Okay, so based on that, what's this? This is x equals 0. If x equals 0, then that's the starting time. The starting time is when you very first put it in the oven. What is going to happen? You end up with time 0, 65 degrees. So you could say something like it's the starting temperature, or you could say it is 65 degrees Fahrenheit when you put it in the oven. Or you could say at time 0, or you could say at the starting time, or something like that, right? At time 0. Okay, And that kind of makes sense why the graph is starting right there, because it's not starting at 0 degrees Fahrenheit. That would be freezing cold. After the turkey has been in the oven for 50 minutes, its temperature is, so this is my x variable, 50 minutes. Its temperature is now this. This is the output of my function. Create a mathematical statement that uses function notation. So my temperature after 50 minutes equals what? 105. So this is technically saying my output, or my y variable, is equal to 105 after my x variable is 50. 50 minutes has gone by. All right, the temperature is rising in the oven. Okay, let's go check out one more example, I think, that we have. All right, the number of miles. This is probably one of the tougher ones on the page. What's happening with the submarine? The submarine is starting at 75. All right, so that is referring to 75 what? Miles. And then it's going to decrease over time. It goes down. It decreases in feet, or I mean in miles. All right, and it's going to go below surface for about 75 miles below surface. And it's going to keep going, keep going, keep going. The number of miles a submarine is from its destination. Oh, I guess it's not going down, it's going to a destination. All right, great. X number of hours. So we got hours here and distance here. And it says, after starting the voyage we have an equation that was represented right here, which means that we're going to have 75 miles, and then it's going to decrease in distance for 15 miles every what? For every hour, x hours. So for every x number of hours, it's going to subtract 15 more miles. 15 more miles. For every x number of hours that go by, it subtracts another 15, all right? Which kind of makes sense. You can see subtract 15, subtract 15, subtract 15, subtract 15, and keep going. The number of f of miles of a submarine is from its destination x hours after leaving port is shown in the graph below. So what is this? This is 2 hours. X equals 2. So at x equals 2, what is the number of miles that it has gone? Well, it's going to be 75 minus, and it's going to be 15 times 2, because here's my equation, and it's really 15 for the first hour and 15 again for the second hour, which is a total of 30. So this is actually 75 minus 30. And you can tell right there that it's sort of after 2 hours that it's about right there. Not 50, it's a little less than 50. It's actually 75 minus 30 is 45 miles, right? So you could even write that there if you wanted to, miles. Find x. Okay, we're going to solve for x. And I'm going to show my work right over here a little bit in this spot. And it says, if we know that the output is 50, so the output is what? 50 what? 50 miles, not the time, but the miles. So if you know that, then we're going to find out what that value is that pairs up with it. Well, it's not exact, so it's kind of tricky. So what do? We take that 50 and set this equal to it. So it's going to be 50 put into this location right here, okay, because it says it equals that. So we're going to set it equal, which is 75 minus 15x, and we're going to start solving that. So we're going to solve by subtracting 75 from both sides. These cancel out, and I get negative 25 equals negative 15x. Then I divide by negative 15. I'm solving for x, trying to get it by itself. So I divide by negative 15, divide by negative 15. And these cross out, and I end up with x equals what? That'll be about 1.66666 repeating, right? So I could write it like that. So it's about 1 2/3. This is 1 2/3 would be my answer of what? Hours is what my x variable is. My x variable equals, based on my calculation right there. The submarine traveled how many miles in 1 hour? We'll go find it. Let's see. There's 1 hour, and it's about right there. And how much less than 75 is that? Well, it'd be 75 minus 15. If we do that, then it would be at about what? Right here. About 60. Okay, 60 miles in 1 hour. Oh, no, it means for every hour, not in the first hour. So let's go back here real quick. It says we're going to have, so ignore that. It's going to actually have how much in every single hour does it go. It travels 15 miles every hour. It decreases 15 every hour. So we're going to write down 15 miles per hour, right? Miles in 1 hour. The submarine travels 75 miles in how many total hours? It looks like 5 total hours is how long it takes to go from 0 hours all the way over to 5. All right, see that distance and that span? That's a total of 75 miles traveled in 5 hours. Should say hours. All right. So let's go ahead and check and see. I think we're all finished up with. Yeah, so there's a test tomorrow. Here, we'll erase this. Fast forward, rewind on this video as needed. Unit 5 test tomorrow. Unit 5 homework packet is due tomorrow, 50 points. Unit 5 review due tomorrow, 15 points. All right, so make sure both of these things are finished up. Got to get some study time in, going over stuff. Make sure you're ready.